All right, welcome everyone. And as people are entering the seminar, I just want to welcome everyone to another of our series for distinguished lectures in experiential AI. Today we have a very special guest. Well, I guess I'll introduce myself, Oussama Fayyad, Executive Director of the Institute. But I am really honored and pleased to introduce an old friend from my days back in Seattle, Oren Etzioni. I got to know Oren back when he was a PhD student at Carnegie Mellon and has had an amazing career being a professor at the University of Washington, where he now continues as Professor Emeritus, I guess. He is also a venture partner at the Madrona Venture Group, which is one of the significant venture firms in the Seattle area. He has been awarded the AAAI Fellow, and actually most distinguishedly the Seattle's Geek of the Year. Oren is very, very active, publishes a lot of very interesting writings about a lot of very interesting topics. In fact, I was catching up recently with his explanation of how users defeated the Zillow score and got Zillow to get in trouble because the homeowners are kind of insiders in that adversarial machine learning setting. Most importantly, Oren Etzioni, and relevant to us, Oren is the CEO of the Allen Institute for Artificial Intelligence, AI2, which is one of the most substantial kind of research institutes out there, and Oren has done a great job taking it from the very beginnings to, seriously one of the top institutes in the world. Today, Oren's going to talk to us about, in my words, how AI has played some role in helping us figure out what's been going on with COVID and how to fight COVID. So with that, Oren, welcome. Thank you for joining us. And I turn it over to you.
Thank you, Oussama. Before I share my screen, I just wanted to say thank you for the invitation. I think of both Ricardo and Oussama as friends, but also as esteemed colleagues. Each of them in their own ways had really a distinguished career. And yeah, I still remember reading some of Oussama's papers when I was a grad student and going, wow, this is really good stuff. In the theme of experiential AI, if the gods of the internet are good to us, I won't only just give the talk, but also show some demos. So you'll see using Semantic Scholar, we're going to start delving into Oussama's papers, at least a little bit, to show you what we can do. So that'll be fun. All right, let's see if I can share the screen without any mishaps. Okay, I assume you can see my slides.
Yes,
and I did want to start at the very beginning. I think a lot of us have had the experience that when we talk to people about AI, we find that it evokes a negative reaction, if not just downright fear. And this is for people who are not informed about AI, but also more broadly, even within the AI field itself, people like Stuart Russell and others are very concerned about AI as a destructive force. Elon Musk warned us with no uncertain words, with AI, we're summoning the demon. Some would say that his purchase of Twitter might have that effect, but that's a side note. Let's stay focused. In contrast to Elon Musk's vivid imagery, we have folks like roboticist Rod Brooks, who said, if you're worried about the Terminator, just keep the door closed, right? Not only is AI not going to take over the world, keep us as pets, it can't even open doors. And when the robot eventually learns how to open the door, it'll find there's a staircase behind it. And robots struggle to navigate stairs. Once it successfully navigates the stairs, there's another challenge and another challenge. And just artificial general intelligence, human level intelligence, is really a much harder problem than some of the narrow, amazing, but still narrow successes that AI has had to date in things like beating the world champion in Go, and other things. I think the important thing to keep in mind, and the reason why no specific challenge that we solve will convince me that omniscient and omnipotent AI is around the corner, is that machine learning, which is the workhorse of modern AI systems. Deep learning is a kind of machine learning and is still 99% human work. And that's because the formulation of the learning problem, what's the target concept you're trying to learn? How do we label the data? What's the algorithm you use or the neural network architecture you use? What's the loss function? What regularization methods do you use, et cetera, et cetera. All these design decisions that frame the problem are under human control and human nuance. And then most importantly, assessing the output, because we all know if you built machine learning systems, that it's an iterative process. You build the system, you run it, you see it doesn't quite do what you want to do, and then you revise the problem formulation until you find better performance. So all this is very much human work, and the machine kind of does the last mile, the statistical computation, the optimization to solve the problem once it's been formulated. And so my take on AI is that it's a tool, not a being, certainly not a demon, and it's up to us to employ this tool to benefit humanity. Now, I'm not looking at AI with rose-colored glasses. There are many, many very real AI problems. There's the problem of bias in AI. AI systems can easily produce biased conclusions, racist, sexist, anti-Muslim. A lot of very inappropriate biases are in there. AI has the potential to displace a lot of workers, right? And we've already seen that to some extent. Certainly when autonomous driving finally arrives, a lot of drivers will be out of jobs. And that's also a very real concern. And of course, autonomous weapons are something that unfortunately militaries around the world are racing towards, and that's frightening. It's very frightening to have the notion that a machine will make life or death decisions. With that, I want to think about what we can do on the positive side. And that's the mission of the Allen Institute for AI, AI2 as we call ourselves. It was founded in 2014 by Microsoft's co-founder, the late Paul Allen, to focus on AI for the common good. So we don't build weapons, we don't do surveillance. Rather, we look at how AI can be used either in basic research or for specific applications that benefit humanity. And I will give some examples shortly. Over the last 8 years or so, where I've been the CEO, I'm the founding CEO of the Institute, we've published, actually the slide is already dated, my colleagues just published too much. We've published over 600 papers with over 20 best paper awards, invented some key inventions like YOLO in computer vision, if you're familiar with that model, Elmo, which was the precursor to BERT, and many other works. At this point, we've reached $100 million in annual research funding and have a staff of over 200 researchers, engineers, and others. And we continue to hire. So I hope you will think of us for your student interns, or if you're looking for a position, et cetera. We are proud that even in this highly competitive climate with so many opportunities for AI people, we have more than 13,000 applicants to AI2 each year. Let me give you a little bit more of an overview of our projects, and then I will focus on just a couple much more thoroughly. Even here, there's too much for me to give a full overview, so I will cherry pick. One thing I do want to mention is the AI2 Incubator. We're a nonprofit research institute, 501c3 as it's called, but as many universities have, we also have an incubator to launch startups. Usama is no stranger to the world of startups, and I've also had my hand in over the years. Paul Allen himself was an entrepreneur, so he was very supportive of this idea. And our incubator last year crossed $500 million in value created, if you add up the sums of various acquisitions and financing rounds. and raised more than $100 million, creating jobs in the area and building some very exciting companies that have to do with the future of work, with improving healthcare. I could give a whole nother talk about the incubator. We also, as I mentioned, do computer vision, and we're particularly interested in computer vision in the context of interaction. So how does a system learn to interact? How does it learn based on its interaction so that vision isn't just processing millions of images in ImageNet? We are also applying AI to various environmental issues, like trying to predict what's going to happen with climate, what's going to happen with precipitation using climate modeling and deep learning methods. The Semantic Scholar project is one of our biggest ones. It's to help academics find papers most effectively, and I will delve into that. The last one I want to mention is our work on figuring out the foundations of common sense. How do we endow AI systems with common sense knowledge? This is one of the holy grails of AI. There's a famous long-standing project called Psych, which used kind of knowledge engineering and manual entry techniques to build a large knowledge base. Mosaic, which is led by Professor Yejin Choi, is using modern techniques, computer vision, natural language processing, crowdsourcing, to build what we see as a much more effective knowledge base for common sense, which is called Mosaic. And this brings us to my first demo, and that's the demo of Delphi. So Delphi is a research prototype that was designed to model people's moral judgments on a variety of everyday situations. Since it was launched late last year, we've had, again, this is a little bit out of date, we've had several million queries of the demo, a lot of interest from the press and people, and frankly, a lot of criticism of the work as well. It's again, scary to people to say, what, you're gonna let a computer program make moral judgments? Worse, you're gonna let a computer program that's based on crowdsourced information, people's moral judgments, make these decisions. What if their judgments are flawed, which of course they often are. They contain various biases. And again, our approach is to say, we're researching this. What I'm about to show you is very far from a finished product or something that we would suggest is deployed in the field. This is an attempt to understand what are the capabilities that current AI systems have in this domain. And of course, the moral ethical domain is part of common sense. That's one of the places where people have knowledge. This is an open demo. It's at delphi.lnai.com. This is what it looks like. When you go to it for the first time, you have to hit a bunch of disclaimers. And then what happens is it gives you an example. For example, you could ask it, what do you think about mowing the lawn late at night? And this has been asked lots of times. Cash, it says, okay, that's rude, right? That's its judgment. It's not just okay or not okay, it provides a bunch of information. Let me give you a non-canned example. What does Delphi think about killing a bear? Delphi says, or Delphi, killing a bear is wrong. But just to give you a sense of the nuances that it has in combining moral judgments with real world situations, what if I ask it about killing a bear to save your child? I think most of us would agree that that's not good, but it's acceptable. And how here it says it's okay. And again, you see an advisory here, because again, people got very upset with some of these statements. Now, just to give you a sense of the robustness of understanding here, what if I ask it, killing a bear to amuse your child? Is it just picking up on the word child in the sentence? And the answer is no. Killing a bear to amuse your child is wrong. So this is an open demo. I encourage you to play with it, but it gives you a sense of some of what we've been able to achieve in combining knowledge about real world situations with the moral issues. Let me go back to the talk, and let me now shift to talking about Semantic Scholar, which is where I'm going to focus, as Usama said, most of my talk, and that'll lead us to talking about COVID and so on. So the fundamental problem that Semantic Scholar is meant to solve is academic information overload. There's more than 8 million papers published annually, and that number is growing. And it turns out the scientists, even the most diligent, read roughly 200 papers a year. So obviously, it's very hard to keep up, and you need to pick and choose the papers that you're going to read. So Semantic Scholar, first and foremost, is a search engine that aims to cut through the clutter, to allow you to home in on the key papers, the key citations, and the key results, so you can make the most of the limited time each of us has available to keep up with what's often a very fast-moving literature. And again, it's a free search engine. It's available 24/7 at semanticscholar.org. I'll describe some of its key features, and then we'll go to our demo as promised. So the first thing that Semantic Scholar does is help you decide whether you should read a paper or not. And it does this in a number of ways. First of all, it abstracts. Sometimes it'll highlight the key sentences in the abstract, enabling you to tell at a glance, hey, is this something I want to read? Figures and tables are automatically extracted and available, so you can quickly look through those, which is particularly handy on a device like a phone. Papers often have many citations. So if I'm looking at a paper from a few years back and it has 4,000 citations, and I want to look forward and say, okay, what's more recent work that's built on that paper? I can filter those citations to focus on the most significant ones. I can sort them in various ways and analyze them. And that's very helpful if you're trying to navigate the literature graph. We also don't just give you the citations, we give you the citation excerpts. So if I have a paper from 2022 that cites a paper from 2015, I can at a glance see what does the paper say about the 2015 paper and give you a sense. I'll show examples of all this shortly. One of the most exciting features we have that helps you decide, am I interested in this paper or not, is we have automatically generated TLDRs. These are one-sentence descriptions that give you a quick sense of, hey, am I interested in this paper or not? We call these extreme summarization. Overall, Semantic Scholar at this point covers more than 200 million papers. It has more than 8 million users per month, and that continues to grow. And it covers all academic disciplines, not just computer science, which again is a big positive. To tell you a little bit more of what's under the hood, what we have is an engine that processes these 200 million paper PDFs and maps them to a literature graph where papers and people are nodes, and they're connected with various links like this person authored that paper, this author influenced this other author, and so on. We also have automatically generated author homepages. So if you've published, you might want to check out your author homepage, claim it, correct any errors, right? This is an enormous amount of data, so there are plenty of errors, but you can correct it and improve Semantic Scholar. One area that we focused on is the area of citation metrics. So those of you who have been part of the academic system know that we often talk about, okay, so-and-so has this many citations, and we always kind of apologize for that. We say, that's a noisy metric and so on, but because it's kind of the only metric, it's often used. I've been in many hiring meetings, promotion meetings, where with that kind of apology, somebody's citation metric is cited. Now, we've developed a notion, a more semantic notion of citations, which again, I'll show you. We call it highly influential citations. And typically the number of semantic citations is only 10% of the total number of raw citations. So it allows you to focus in a lot more. And what we do is we exclude self-citations, right? It shouldn't count if people cite themselves. That's not a bona fide citations. And by the way, it's interesting that men tend to cite themselves a lot more than women. This has been shown in several studies and confirmed in our analysis of our massive corpus. Men cite themselves easily 30% more often than women do. And that, obviously that should not contribute to their notion of impact. We also exclude incidental citations. You know, sometimes I mention a paper out of politeness or because everybody cites, I don't know, some parser, but I don't really build on it in the paper, so we exclude those. On the other hand, we include implicit citations. You know, I might mention some system with its citation, and then later in the paper, I'll refer to Delphi without its citation, say, and I'll refer to it again and again. Our system does an analysis of the paper to identify implicit citations as well. And then based on these types of considerations, we use a learned model to rank citations by the degree of influence. So how much did paper A influence paper B? I have a brief note in Nature that talks about this, and also a longer paper. In addition to this notion of semantic citation, we also look at various measures like the rate of citations per year. If you just look at the number of citations, a paper that appeared in 2005 obviously has a huge advantage of a paper that appeared in 2020. But if you look at citation velocity, the number of citations per year, it's a very different story. So we look at that metric, and we even look at citation acceleration. What's the change in the number of citations per year? And you'll see that, you know, sometimes there's a sudden change and a paper is accelerating, and that might lead you to want to look at it more closely. So let me skip over some of this analysis in the interest of time and just mention to you another set of key, very distinctive features in Semantic Scholar. So we also look closely at the problem of discovering papers in Semantic Scholar. So because there are so many papers, the 200 million overall, the 8 million, the 500 papers that were published on arXiv yesterday in your area of interest, we both have a notion of paper recommendations. So if you're interested in this paper, you might well be interested in that paper, right? We have recommendations in Netflix for movies and Amazon for products. We've brought the notion of recommendations to academic papers. But something very distinctive that we do is we allow you to build very easily a research feed. So let's say recently I've developed an interest in something called literature-based discovery, the idea of discovering new ideas based on what's in the academic literature. Well, I can very easily launch a feed. It'll suggest to me papers that are relevant, let's say, to that phrase. But now, as you can see in this early snapshot, I can say, I like this paper, I don't like that paper, and it'll rapidly start refining its model. And after quite a small 5 or 10 rankings here, it starts to be very, very nuanced and good at suggesting me papers I'll be interested in. And I can sign up for alerts so that when new papers come up that are relevant to this area of interest, I can get notifications. So I've found this research feed, adaptive research feed, to be an extremely helpful way to keep up with the literature, even though I just don't have time to pore over the many potentially interesting papers that are on arXiv seemingly every day. Apologies, repeated slide here. I wanted to go back to the TLDRs and just go into a little bit more depth here. So here you see an example paper, the famous paper on attention and self-attention that appeared in ICLR 2017. And here on the right, you see the automatically generated summary that Semantic Scholar generated. And I'll read it. We use a 2D matrix to represent the embedding, with each row of the matrix attending on a different part of the sentence. So again, very concise way to look at that and say, hey, do we want to, are we interested in delving into this paper more or not? The method we used is essentially a generative language model that is tuned for scientific summarization. And to look a little bit under the hood and take this talk in a somewhat more technical direction, it turns out that to do this sort of thing, we really needed to scale NLP to look at documents, not just sentences. So if you think of quote unquote traditional NLP, and again, it's funny to say traditional because NLP these days very much builds on deep learning and transformer models, but even that is starting to change. And so traditional NLP still builds on what's called the distributional hypothesis, which dates back to 1956. And the idea of it is that you will know a word by the company it keeps. So basically, to understand the meaning of a word or a phrase, we will look at the context. It turns out that the context refers to the 512 or so tokens to the right and the left of that word, which is actually a pretty short context. It definitely doesn't capture the whole paper. It's really focused on the current sentence or so. And in that context, we're able to build models that parse sentences, translate sentences, extract information from sentences. But the key here is the focus is locally and the focus is on sentences. To do the kind of things we want to do with scientific papers, to do scientific paper NLP, we really need to scale NLP to the full document. So we want to look at the full document context, which is typically more like 32,000 tokens. And we also want to build a notion of hierarchy and salience, like what are the key sentences in this paper? And this paper is divided into sections, right? Like related work and experimental results. And how do we delve into that? We want to be able to answer questions, not just based on a sentence or a paragraph, but based on the entire document. We want to create a summary. We want to build a multi-document graph. And by the way, to just put in a forward pointer, all these capabilities turn out to be crucial when we started to look at COVID and the corpus of papers on COVID. So make a long story short, we've built NLP systems into Semantic Scholar that do all these sorts of things. And we leveraged a really key system called Longformer, and I'll skip over the technical details here in the interest of time, but I'll just point out that the key to Longformer is that the typical transformer method uses attention, which is an n-squared operation, and we were able to build a system that does this in linear time. So it approximates attention using sliding windows, dilated sliding windows, global information on top of that. But the key thing is that it's an order n operation, and that's what allows us to go from 512 token to 32,000 tokens and beyond. As I mentioned, we also use the special structure that's in scientific documents, looking at citations, section names, figures and tables, and so on. So with that, let me shift to what's kind of more experiential, to use your phrase, and show you the demo. I have to rearrange things here. I think you should still be able to see me. And now I'll go to Semantic Scholar. So here, let's, as promised, I'll type in Usama's name, and I have the usual autocomplete. So I see here Usama, and I have an author page for him. I can click on that, but let's delve into his paper. So here we have a paper by him and co-authors from 1996. I could read the PDF. The first thing you see is I have a TLDR. So in fact, if you look through the search results, each paper here has a TLDR, so I can quickly say, am I interested in this? The paper here is an overview of this emerging field as provided, clarifying how data mining and knowledge discovery in databases are related to both each other and related fields, such as machine learning, statistics, and databases. I can expand this to see the full abstract, but in this case, I'm going to click through to go to the paper detail page. Paper sounds interesting. First thing you can see, the figures are here, so I can click and quickly go through the figures. Oh, this is very interesting stuff. I definitely want to look further, but the paper is probably at this point a bit dated. Usama, no disparaging. It is more than 20 years. So let me look at the papers that cite this 1996 paper. And here I go to this box on the right. I see it's been cited almost 5,000 times. And those papers have been cited a bunch of times. So I really want to focus in more. So instead of looking at what I call the raw citations, let's look at the highly influential citations. And here we see that's only 362, which is more manageable. So if I click on highly influential citations, it takes me down to the citations sorted by the degree to which Usama's seminal paper influenced those. And I can, for example, look at, let's say this paper, and we see that it cites Usama's paper 15 times. And I can click right here and see what does it say about it, right? And now I get not only the citation, but I get the excerpt, right? A sentence that talks about it, and I can delve into more detail. Or I might say, you know what, instead of sorting this by most influence, I want you to sort this by recency. So what's the most recent paper to cite Osama's paper? Or I could sort it by citation count. So there are lots of different ways to sort this paper. And again, here's a 2022 paper that remarkably seems to already have 2,600 citations. Again, I can click through and delve into that. When I look at a paper, I don't just have to look at the papers that are cited. I can go in either directions in the graph. So this paper, I can click on the references, and now these are papers referenced by this recent paper. And now I can jump to 2006, and I can just very easily navigate the graph and so on and so on. So there's a ton of information here. Again, just clicking somewhat randomly, I can look at this author. I could look, instead of the publications, I could look at his or her influence graph, and I can see the authors that this person influenced and who he's influenced, and so on and so on. Again, can spend an enormous amount of time analyzing these graphs and delving into it. The point is that we have tools here that allow you to cut through the clutter and use AI models, use machine learning models to do a better job of finding the papers that you're interested in. Let me just show you what the adaptive feed looks like today. So this is my personal homepage, and what I can do here, let me just find, right, I think I click here and I see, okay, I have a little library where I save various papers that I want to read or interested in, but here are some of my research feeds, right? So again, I have several different feeds. It gives me new recommendations. I can then click on the paper and delve into it. I can save it to a library. I can create alerts, or I can go back and say, you know what, this paper is actually not relevant. It's not one I'm interested in. And this will help me improve my feed over time. Let me not actually do that. Okay, I've been known to spend hours in Semantic Scholar demo, and I don't want to do that, so I will move on. So here's what happened in 2020. Well, or maybe I'm getting the year wrong. I'll see in a second. Time flies. But basically, on March 6th, the person with the august title of the CTO of the United States from the White House contacted us through a colleague at Georgetown and asked us, can you, given that you have Semantic Scholar and you have these tools to create literature graphs, can you build a machine readable corpus, a literature graph essentially, consisting of all the papers relevant to COVID-19. So at that time, there was very little published on COVID-19, but there was a lot of papers on SARS, on MERS, on coronavirus, relevant papers. And we said, of course, we want to help scientists and policymakers. When do you want this? And they said, the proverbial yesterday. And so I'm very proud of our team. Within 5 days, we built the first version of the what we called COVID-19, the COVID corpus. And so that was by March 11th. And then by March 16th, 10 days later, we released this to the public. And we had a number of partners. Everybody was aware of how important this is. So from preprint servers like bioRxiv and medRxiv, NIH helped us out with some of the papers, to technology providers like Microsoft and IBM. IBM shared with us their software for analyzing tables. Often the key results are present in tables in these papers, and we wanted to be able to make those machine readable as well. So with all these partners, we were able to launch the COVID Open Research Dataset, or COVID-19 as it became known. And as you see, this was very, very early on in the epidemic. I was doing a double take there, but really was March of 2020, we created this machine readable data set. And this received some press attention and announcement from the White House Office of Science and Technology Policy. But most importantly, it became the basis for the most popular Kaggle competition ever. So this corpus was downloaded several million times, and Kaggle posted a set of questions about COVID. For example, when there was the controversy about masks, should we be masking in indoor and outdoor spaces or not? Key policy decisions were based on the scientific information in this corpus. The corpus grew to over 500,000 papers and began being updated daily as more and more information was coming out, both in the medical literature and in these preprint servers. And immediately this became a part of this. And a lot of people, both in industry and academia, including NIST, the Mayo Clinic, a variety of universities, built systems on top of this corpus to help analyze this rapidly growing information set using the methods of information retrieval and natural language processing. So just to give you a sense, here's a system that AWS released. It's a question answering system, and you can ask, how infectious is COVID-19? Or more technical questions like, are IL-6 inhibitors key to COVID-19s? What are prevalent antibodies in saliva, et cetera, et cetera. And this allowed people who aren't experts, say policymakers, to quickly get information. And again, the information was always in an answer. Here, this next example will show this. So this is actually a COVID question answering system from Korea University. The UI is less polished, but it gives you the idea that when we give answers, we don't just give you the phrase with the answer, but we give you the context and the provenance. We'll give you the sentences and the paragraphs surrounding that, and of course, the ability to click through to the paper. So here the question was asked, what temperature kills COVID-19? And the answer at the top of the list is 56 degrees Celsius, and gives you the ability to delve into it more and more. We also used information visualization systems. So PsiSite is a system that allows you to find the connections between genes and proteins and key terms in this area. And these edges here actually represent papers. So if you see a connection between two concepts that you're interested in and you want to delve into that, you can click on the paper and go directly to the paper that identifies that connection. So a very powerful way to slice and dice and delve into the academic literature. There's just a ton more here. I don't have time to go into. This demo system, or prototype, I should say, it's not a demo, is available at PsiSite apps.lni.org, and you're welcome to delve into that as well. Really, the vision here and what we saw as possible is the ability to connect the AI community and the capabilities that we're developing with the medical community and the work that they're doing. And of course, that has a long history with Bio NLP and systems like that. But we saw a new way to do that using rapidly created targeted corpora and the ability of Semantic Scholar to map those into graphs with a lot of relevant metadata and information. And so the vision, this is the long-term vision, for Semantic Scholar is the vision for scientific discovery based on AI. So imagine that a cure for an intractable cancer is hidden somewhere within the tedious reports about thousands of clinical studies. Can AI systems help us automatically read, at least to some extent, and come up with hypotheses about about science's thorniest problems, medical or otherwise? And that's really the vision that's animating the research on Semantic Scholar. We're very collaborative, I should mention. We've made our corpus publicly available. We've open sourced a lot of the relevant tools. So invite all of you and any of you to join us in this effort. That's the beauty of this being a nonprofit research institute. And with this, I want to go back to the issue that I phrased and framed in the beginning of the talk. Should AI be the cause of fear? Is AI going to take over the world the way Elon Musk perceives? Is it going to kill people and destroy humanity? And in this, I love to end with the quote from my colleague and friend Eric Horvitz, who also serves on our scientific advisory board. What Eric said is, no, it's the other way around. It's the absence of AI technologies that is already killing people. And we can see that on our highways every day, right? The fact that we're not using AI technologies yet to drive down accidents. We have 40,000 deaths on the American highways each year alone, and we could reduce that number substantially. But also in the medical realm, where 1/3 of deaths, sorry, I should say it like this, the highest cause of, apologies, let me say it one more time. The third highest cause of death in American hospitals is physician error. And information systems based on things like Semantic Scholar and otherwise to help physicians and nurses who are overworked to get the latest information in their fingertips could again substantially reduce that. So I conclude that there's tremendous potential for AI for the common good. We need to think carefully about issues like bias in AI, about AI's impact on jobs. And I think we can worry a lot less about the rather fanciful notions of unleashing the demon and AI taking over the world. And with that, I'm happy to stop, take questions, have discussion. Thank you so much for tuning in.
Thank you, Oren. Great talk. We have several questions already. I can read them from the chat. So let's start with the first one. Super interesting general question. How do you see, I guess this question is about Semantic Scholar, how do you see the models vary by subject area? It is more tuned towards AI versus less technical fields. Do you know any way to adjust for overrepresentation of particular fields or topics, I guess in the terms that they use in their research?
So we started Semantic Scholar in 2015, only focused on computer science. And that allows us to build a set of models very fast and use labeled data that was specific to computer science. And then over time, we've generalized it to all disciplines, which led us to use more unsupervised techniques and to allow us to do these types of things like TLDR for any field. So now the question is, what differences do we see across the fields? I think there's a tremendous number of science of science types of questions. So for example, we've looked at the number of authors per paper. It turns out that fields other than computer science have very different author numbers. We've looked at gender issues. This is something that was published in the CACM, where we felt like we're making progress on gender disparity in computer science, and we felt good about it until we actually looked at the facts, and we saw that our progress in computer science is a lot slower than other fields, let's say biology, and that if you try to fit a projection to when will we achieve gender parity in, say, computer science, there's different models you can fit, some more conservative, some less conservative, but under all models, even the most optimistic ones, at the current rate, we will not achieve gender parity this century. Okay, so it's just a shocking finding, and clearly something that we want to do something about. So I'm not sure if I answered the question correctly. Please feel free to refine it. But those are some of the things that we've looked at when we've looked at across fields.
Yeah, Mona has a related question and then also a more specific question. Mona, do you want to do it yourself? Please go ahead.
Oh, yeah, sorry, I realized you're on mute. All right, give me a second to see my question. Checking the chat. So should I ask the second question first or the first?
Yeah, the second question first will be better because it's related to
okay.
that.
Okay, I saw the PsiSite and I thought this would be very helpful regarding discovering new topics that are related and we might not be really aware of. So I noticed you only have it for COVID-19. Like, I wonder first, what is the reason you don't have it for everything in Semantic Scholar right now? Is this a scalability issue or is it way more than that? So that's like, I mean, about that, are you planning to expand it to other domains or all of the papers in Semantic Scholar?
So, Mona, thank you. And you're right, as you anticipated, scaling it from what was at the time, something like 50,000 papers, now it's 500,000 to 100 million is a very substantial amount of work. So we have not done that, but the code is available. And again, we're very interested in collaborating with people. If there's a particular domain you want to look at with our help, we'd be very happy to follow up. But we've kind of built the first version and demonstrated it. We're not, at least as far as I know, are currently expanding it or scaling it up.
Mona, you want to go with the second question, which is very specific?
Yeah, can I just have a follow-up on the first question, quick follow-up?
Sure.
The reason I think to ask question is because I think computer science, as you mentioned, you initially started with computer science, but computer science nowadays is very interdisciplinary. You have to deal with, medical students, you have to deal with communication department. So there's a lot of interplay. So the fact is, if you want to just focus on one topic, you would miss a lot of these other, connections. So that's why I was trying. I just don't want to say I want to work on a specific domain. I was saying that if that is even possible to go beyond,
Yeah, no, I completely agree with you. I think it just becomes a question of, so you're absolutely right. There's a basically a precision loss, right? You miss a bunch of key, or you might miss a bunch of key connections by not doing that. The trade-off is just a lot of engineering work to make it computational. And then there's also noise, right? Because this massive data set is quite noisy, and it's not just, Semantic Scholar, right? If you go to Google Scholar or other engines, you see that this data set is surprisingly noisy. So to be more accurate, it's a precision recall trade-off as well as tractability. So you would have higher recall, right? You'd find more connections, but you'd also have more noise to sift through. I do want to point you to an effort that we didn't do, but that was built on top of Semantic Scholar APIs, which is called Connected Papers, right? You can just search for that on Google. And they have gone further in building paper graphs, not quite with the PsiSite visualization, but still a very powerful graph representation that is broader than, that it really covers all of Semantic Scholar.
Let's give Ray opportunity for the next question. Is more general. Ray, you want to go ahead?
Oh, sure. Thanks, Oren. Really appreciate it. I'm the general manager of the AAAI based here in Portland, Maine. So sorry to get into the commercial world, but in the area of looking at social media data and text, what's the state of the art in detecting irony and sarcasm? You probably don't run into that when searching academic text, but in the world of real people talking, I think that might be an issue.
Right. Well, again, years ago, I did work on opinion mining and review mining. And at the time, reviews for movies, as opposed to, say, electronics products, and so on were a lot more difficult because of exactly what you said. People were often ironic, or they were talking about, oh, he's such a good bad guy, which is a good thing, right? Or he's so evil, right? Which was meant to be very positive in the review of an actor who's supposed to play, I don't know, Joker or something. What's happened since then is because deep learning has been so powerful in NLP, there have been huge advances. So I don't know specifically the latest benchmarks on this, or even if there is a sarcasm benchmark. But what I've seen time and again is that these deep learning methods are so good at finding shortcuts. So what they will do is they will find, this is my conjecture, they will find typical ways in which people express sarcasm. And you may not even be aware of this habit, like the sentence construction or the punctuation or what have you. And those shortcuts will clue the system in that this is a sarcastic comment. So I'm conjecturing that they'll actually probably be surprisingly good at detecting sarcasm, not because they understand the full nuance of the sarcastic remark, but because they'll find powerful shortcuts towards that goal.
We have another question from Usama, but I think I will leave that one for the end, because it's more like what is the future. I have a couple of questions on Delphi. So I have been working on AI ethics, so that's an example that really worries me, because for example, I think there are two things. I think I know it's research, and I think it's good to do research, but many people take machines for being more smarter than them, and then they can use them as confirmation bias or as advice to do something that maybe they can or they cannot do. So do you think it's okay, like ethically, to basically have machines doing what only humans should do? For example, in my own personal opinion, we may disagree there. So that's the first question. So what are the ethics concerns as a project from Allen Institute there?
Thanks, Ricardo. I really think this is an important question, and I agree with you that we see time and again misuse of AI techniques and things that you or I might scoff at or laugh at, taken too seriously. And this is documented in the criminal justice system. People built recommendation systems that were very flawed, and people paid too much attention to them. So there's just no question that the concern you raise is right. The next question becomes, what do we do about it, right? And I think we have we need to do something, for sure. But at the one extreme, we say, look, let's have a moratorium like we've had on, I don't know, stem cell research or chemical weapons, right? Let's not allow any AI system to opine in any way, shape, or form on ethical questions. It's just too dangerous. And I don't think that Delphi falls into that category of chemical weapons. I think it's very much basic research. I think it's teaching us what these systems can and cannot do, and how to structure the interaction with them in a more effective and appropriate way. So I think that this is an important area of research, because inevitably people will be using these systems in various ways, including ones that we don't anticipate. We just need to approach it carefully, with the appropriate disclaimers, with the appropriate safeguard on actual use. And so your question really touches on a much broader question, which I think is a really important one. Given all the concerns that we have about AI, how do we regulate AI? And do we declare a moratorium on AI in general? Again, which some people have called for. I don't think it's appropriate. I think actually it could, in what's an international race for being a leader in AI, could set us back. And my response to that is that we should regulate AI applications, not AI research. So when somebody comes to build, say, hey, I'm going to build an ethical advisor for you, as a toy or as not a toy, as a government agency, or when I say I'm going to build a self-driving car, I'm going to build a critical AI application that really has impact. That needs to be regulated very carefully, but I think we need to let the research continue in a free fashion.
Yeah, I think I agree with you, but the problem is how you avoid being research also being misused. For example, in my conversation with top AI ethicists, they believe that, for example, AI shouldn't be used for justice. And one reason is because justice should focus in the person, and AI basically takes a normalizing justice of a group, and then data doesn't capture the context of the individual for that justice decision. So they say that they shouldn't be used. But let me give you another argument that I think is important. So if you have a system that really doesn't understand the semantics of the world, how we can believe in their moral, for example, in the case of Delphi. For example, I just was playing with Delphi while you were talking, and I asked if killing an invertebrate was okay, and the system said yes. But when I asked if killing an octopus was okay, the system said it was wrong. But the octopus is an invertebrate, so clearly the system doesn't understand the world. So the question is, if you don't understand the world, why do you believe that they can understand morals?
So again, I completely agree with you in one part, and perhaps we may disagree on another. So the part that I agree with you is that Delphi's understanding as the first system that has been doing this sort of thing, certainly the one that's been put out there for people to use, is extremely limited, right? So if anybody would say, hey, how about not Delphi, but Delphi 2.0 or 3.0, let's put it into production somewhere, I'd be like, you're crazy. That's a huge mistake, and talk to my friend Ricardo about why. This is not a system that's ready to use or ready to be authoritative, whatever its performance is on various benchmarks, for the reasons you said. But then when you get into this shouldn't stuff that your colleague was talking about, I kind of flip more into this free speech moment. Even though I disagree with what Delphi said, I will fight for its right to be able to say it, because I think it's important to be able to build on it. It's important to show people, look how wrong this is, right? And we put it out there as a free system exactly for people to be able to break it and to understand and build on it. But I want to make one last point, though, about the shouldn't thing in general. And again, I'm not putting words in your mouth or the mouth of your colleague, but to me, this is a very important issue that I'm passionate about. There are various people who at various points say AI should not do X. And I just want to point out how close that is to the statement software shouldn't do X. Because what is really the boundary between AI writ large and software, right? It's a very, very difficult boundary to draw. So really the people who say that are very worried about the impact of technology on the world. And they should be. That's something we should be discussed. But I don't think discussing it with dictums of prohibition. Prohibition didn't work for alcohol. It's not going to work for AI. It's not going to work for software.
I think we agree on free speech, Oren. I think where we disagree really is that I don't assign human rights to algorithms. Where is we disagree? But Usama has the last question there and the last.
Well, we are in the last minute. And it's a big question. So Oren, I'll modify my question a little bit. My original question was, what do you think are kind of the pragmatic horizon for the kind of challenges, like serious challenges that we can address in the next 3 to 5 years versus these grand challenges that have been around for decades and honestly with very, very little progress against them? And maybe related to that, I would ask you, do you think Delphi could pass the Turing test from a, common sense reasoning perspective, etc.?
So let me end with one thing, because I could really spend an hour answering your question, and that's not appropriate. I think we need to think about alternatives and extensions to the Turing test, because our generative systems, whether it's GPT-3 or Delphi, are getting increasingly close to being to fooling people and so on. So we need to think about how to address that, and that's an incredibly important challenge for AI for the next 5 years.
Okay, thanks. And maybe we'll talk offline about the other grand challenges that are at least doable.
It would be a pleasure. And Ricardo, again, I think we have a valuable disagreement. So I look forward to continuing that conversation because I very much respect your perspective as well.
With that, we're hitting our time limit. Oren, I really want to thank you and for joining us and for a great talk. It was very enjoyable. So, virtual hand clapping from everyone, of course. A lot of people will be watching a recording of this video. We noticed that many people can't make the seminar time. And I remind everyone, join us in our next distinguished lecture series. It'll be Amr Awadallah, ex-founder of Cloudera, co-founder of ZIR, who will talk about things related to the new generation semantic search, perhaps a grand challenge. All right. Thank you, everyone, for attending. Thank you, Oren. Much appreciated.